This was a 1949 electronic version of tic-tac-toe, which was considered the first game and did not use any physics calculations. Only a few years later, an electronic game called Tennis for Two was created, which utilized basic physics calculations, including wind resistance. Since then, physics engines became almost mandatory and almost all games utilized them. Space War specifically was revolutionary for its time because of its use of physics and mathematical calculations to compute ship motion and gravity. So we all know this game, Super Mario Bros. Although it may seem like the simplest game at first, this was a revolutionary game because it was the first one to incorporate jumping action and real-world physics such as friction and momentum. This led to the creation of ragdoll physics, which is the implementation of somewhat realistic physics and allowed for realistic death scenes and skeleton modeling. So how is calculus involved specifically? Well, calculus is all about change, or change over time. And physics engines focus primarily on rates of change, and they constantly use differential calculus and integral calculus. These rates determine the velocity and acceleration vectors of a particular particle, and the block of code being constantly looped is updating these vector values billions of times a second. These are the derivative formulas that the physics engines process. To get the velocity, it takes the derivative of r and the derivative of t, and does the same process with acceleration. Sometimes, the physics engines require to do some integration. Here are the integration formulas that they calculate. So a little more how these work. First, an object appears and it starts moving. Then it comes into contact with another object, so therefore its properties of motion change, and we result with a collision response. To put this into perspective, there is the physics engine and the collision engine. The programmer defines the physics and how the collision will affect the object. It detects the collision, sends it over to the collision engine, then it calculates a new vector value, in which it returns back to the physics engine and displays it as an event. It sounds like a lot to grasp, but luckily, there are already numerous professional physics engines out there, such as Havoc and Unreal Engine 4, that do all the calculating for us. Because of calculus, physics engines can now process changes in vector values in only a second and with essentially no work at all.